4671.1, this is a laboratory class, which means majority ng oras ay dedicated to you doing the course materials, which in today's case is experiment 1, which is measurements, uncertainties, and deviations. Pero before we get to that, so I'd just like to remind you guys na lahat ng requirements dito ay by group. So, to summarize, yung groupings natin dito again. So, Gian Belonio, Jamie Katindig, and Jace De Asis. Another group, Dariel Fabia, Frederick Fabilio, Aliana Jimenez. Group 3, Rafael Locsin, Frances Maranan, and Janelle Marasigan. Group 4, Patricia Mostiero, Denise Palasige, Shimon Peranca, and Group 5, Rejoice Perucho, Bilsaret, and Miguel Tamase. So, apologies if I did not pronounce your names correctly. Pa-correct na lang ako kung may mali. But in any case, pag gagawin nyo na yung course materials, I'll leave it to you guys to contact each other para gumawa kayo ng arrangements on how you will do the courseworks. So, regarding these groupings, any questions so far? Okay, wala naman. Okay. Rinig niyo ba ako, guys? Hello, hello. Teka, adjust ko muna. Admit. Okay, so okay naman. Okay, great. So let's get started formally on the lesson. So today we will be handling measurements, uncertainty, and deviation. So sa physics or any science, we do measurements. So measurements are a way of using mathematics to extract quantities from things that are all around us. For example, ang isang ruler, pwede natin gamitin to measure length. Alternatively, we can use a meter stick or kahit anong length measuring device. So, kapag mag-measure naman tayo ng time, you can either use a stopwatch or just use a clock. So, using these devices, we can extract numbers from physical quantities all around us. When we do measurements, they are not perfect. In fact, laging merong margin of error yan ang pag-measure natin kasi it's not always that na pwede nating saktuhin ang pag-measure natin. When we do measurements, there are two main types of errors. These are just two out of many. So ito yung pinaka-common. So random errors, which are small irregularities in measurements. So halimbawa, kung hindi ka consistent sa measure mo or pag stopwatch mo, ganun. This can be due to any variety of factors that are not always in your control. One type of other major error is a systematic error. So, ang isang systematic error ay isang faulty assumption sa device. So, halimbawa, if you are using non-calibrated weighing scale, posibleng halimbawa mag-measure ka ng weights ng mga bagay na ipapatong mo doon. Pero kung hindi siya calibrated, lagi siyang maging off by a certain amount. Kasi faulty assumption sa device at magkakaroon ka ng constant shift in your data, whatever you measure. So when we do measurements, normally you do it multiple times. And when you do measurements multiple times, you will inevitably have to consider the concepts of accuracy and precision. So when we talk about accuracy and precision, these are two related but not identical concepts. So for example, ito, nag-measure ako ng time for 10 trials. So accuracy is when your measurements are close to the true value or the theoretical value. So for example here, dito sa slides, the example is of a archery target board. So you can have cases where you have low accuracy, low precision, which means that all of your measurement trials are all over the place. But for a case where there is high accuracy but low precision, notice here that your measurements, which are represented by your black dots, are all close to your bullseye. So basically, in this case example, the true value or theoretical value or correct value, whatever you want to call it, close lahat ng measurements ninyo to that, even though magkakalayo sila from each other. Now, on the other hand, let's look at this case here with low accuracy and high precision to define what precision is. So kung mapapansin nyo dito, all the black dots, which are your measurements, are close together. Magkakadikit na nga sila, but all of them are far from your true value or bullseye or target. So using this example, what we can define is precision. Sorry for the pangit na penmanship, guys. So measurements are close to each other. So that's how different these two concepts are, although they can be in harmony with one another. For take this example here. Kapag high ang accuracy and high ang precision, all of your measurements are close to each other, and at the same time, they are close to your target value, true value, bullseye, or whatever you want to call it. So regarding accuracy versus precision, do you guys have any questions? Wala naman? Okay, great. Now let's move on to measurement uncertainty and deviation. Wait lang, I'll have to stop share saglit. Pardon the temporary intrusion. Okay, where were we? Teka lang. Zoom. Okay, so now we move on to measurements, uncertainty, and deviation. So just like I discussed earlier, a measurement is anything that is quantified. So yun nga, our basic quantities that we can measure using basic devices, you got length and time. Well, you can also use weighing scales for mass and whatnot. So when you do measurements, it's usually represented as both a number and a unit. So the unit is very important and not just the number. Kasi ang units are what we use to differentiate one quantity from another. For example, kapag nag-measure ka, nagamit ang kilograms, alam mo agad na mass yan. You can't use kilograms to measure length or time. And then in the same vein, if you measure and express your quantity in meters, that's how everybody else knows that you are measuring and presenting a length. And just like I explained earlier, measurements can never be exact. Maraming dahilan kung bakit hindi pwede maging exact ang isang measurements. For one, pwedeng limited ang measuring device ninyo, pwedeng may fluctuation sa environment, pwedeng nagkamali kayo sa pag-measure talaga, and other things. So lagi may margin of doubt na nag-exist sa isang measurement. So let's take this example. Let's take this image of a pencil that's measured using a ruler. So ang length measurement niya, tinapat niya sa 0 point yung tip of eraser of the pencil. However, if you look at the other end, dun sa panulat na end ng pencil, the measurement does not coincide with any one particular line doon sa ruler. The measurement here is 5.65 cm, pero dahil nga hindi sumakto dun sa measurement line ng ruler, this means na limited yung device natin. And this limitation is represented through this term here, yung plus minus 0.05 cm. This is how you represent your uncertainty. So, the uncertainty tells us about the quality of the measurement, and it's a range of values where your true value lies. So, tingnan natin itong example na to. Uncertainty is reported in two ways, absolute and relative. But let's look at the absolute uncertainty first to get a clearer picture of what this uncertainty is about. So, ang example niya dito for an absolute uncertainty is writing 54 plus minus 0.5 kg. If I were to read that, 54 plus minus 0.5, let's skip the units for now. Pwede ko siyang i-rewrite into a mathematical interval. So 54.5 minus 0.5 to 54 plus 0.5, or 53.5 to 54.5, or basically 53.5 let x be your quantity, 54.5. So using different mathematical notations, we can represent our uncertainty in this way. Ibig sabihin lang nito, yung true value or the actual length that you are, or mass, or whatever you are measuring, lies in this particular interval here. So when we define the quantities we use in representing uncertainties, itong number na ito is the central value of your measurement. Si central value ang magiging pinakagitna ng interval where your true value may lie. So when we represent uncertainties, ang absolute uncertainty must always have only one significant figure. And the central value must have a significant figure only to the place value of the uncertainty. So I think you already have access to the supplementary slides. If you need a refresher course on how to represent significant figures, you can use these supplementary slides. Kasi meron ditong examples of how to represent significant figures. For example, this number, 1,200, will only have two significant figures if there is no decimal point. But if it does have a decimal point, you have to count every number here. And if you have a decimal place quantity, yung i-count mo lang na significant figures, 5 significant figures daw, this will be 1, 2, 3, 4, 5. So basically, the first significant digit after your 0.00 something. So, isang partner ng significant figures lagi ay rounding off. So for now, I will leave it to you to refresh yourself on this. So using these rules, how can we correct these incorrectly expressed uncertainties? So we have here, dun sa correct column, tingnan mo, one significant figures, lahat ng uncertainties natin. So in this case, itong last one, walang decimal point. So one significant figure lang. And all of them have central values that match the place, ones place, tenths place, and etc. They match the uncertainty. So let's have a few examples here using the incorrectly presented uncertainties. So yung una dito, 766.0002 plus or minus 0.52. So, mali ito in two ways. Parehong rules ng uncertainties ang na-break dito. So, first, to correct this, gusto natin na gawing one significant figure lang si uncertainty. So, to do that, we will have to round off. So, how do we round off? Let's see. Let's look at the round off rules. If x is equal to 0.5, equal to 5, so ito dito, gusto natin i-limit dito sa figure na ito ang uncertainty natin. And there are non-zero digits to the right, we round the number up. So basically, first rule, the uncertainty must only have one significant figure. So we round this off to 0.6. Round this off. Now, the second rule of uncertainties is the central value must have a significant figure only to the place value of the absolute uncertainty. So if you recall, the place value is just a limit or a label pala for each digit that's a part of your number. So, si uncertainty mo only extends up to the 10th place. If you remember, yung sa first decimal point is the 10th place. So, dapat i-round off ko din itong central value ko in such a way that hanggang 10th place ko lang siya may susulat. So, the correct way to write this uncertainty would be like this. So in a similar manner, we can correct the others using the two rules of uncertainties. I'll leave it to you to figure out how to correct these, but it's not required, although it will be useful sa actual exercise. So another way of expressing uncertainties is by using relative uncertainties. Ang relative uncertainty is basically percentage. It's a percentage uncertainty. So the way to convert from relative to absolute uncertainty and vice versa is just to convert your uncertainty into a percentage. So tignan niyo itong example ng manual dito. 54 plus minus 0.5 yung original, pero kinonvert lang niya into a percentage. So if you just to refresh yourselves, the way to convert uncertainties or any number rather to a percentage, it's just that number, which is a part, divided by your whole times 100%. So in this way, di ko na ipapakita yung details, pero the final result will be 0.9%. So just like with your absolute uncertainty, your relative uncertainty must also only have one significant figure. However, yung second rule, which concerns the place value, is not anymore as strict. So regarding absolute and relative uncertainties, do you guys have any questions so far? Wala naman. Okay, so let's move on to uncertainty propagation. So Measuring things with uncertainties is one thing, pero normally, these quantities are used to calculate other quantities. Halimbawa, nag-measure tayo ng mass at ng speed, but we are to calculate a momentum which is P equals mv. If your mass and your velocity has its own uncertainty, paano mo gagawin yung calculation? Especially if your momentum also needs to have its own uncertainty. Well, dito pumapasok ang uncertainty propagation. So, how you deal with uncertainties when using them in mathematical operations depends on what you're doing. For example, kapag nag-a-add tayo ng uncertainties or ng quantities with uncertainties, the measurements of different units cannot be added or subtracted. So this is a standard thing that you will encounter sa 71 din. So you cannot add, halimbawa, you can't add kilograms to seconds. That doesn't make sense. Anong magiging resulta nun? Wala. That's impossible. What you can add is the same thing lang. Kilograms plus kilograms, meters plus meters, etc. So this also applies to uncertainties. So sinasabi lang dito, the absolute uncertainties of measurements will always add up regardless of kung mag-add kayo or subtract ng central values ninyo. So ang example niya dito, 82 plus minus 1 plus 105 plus minus 4. So kapag nagsusubtract tayo, what we do is isusubtract ito to get minus 23. Pero in either case, laging i-add ang uncertainty mo. So that's how you get this 23 plus minus 0.5 here. So in the case that uncertainties gain more than one significant figure, i-round off mo lagi yan and adjust the central value accordingly. Normally, if you want to do this rounding off, gawin nyo lang lagi sa last step yan para hindi mag-propagate ang error because it can propagate just like your uncertainty. So next, multiplication and division. So this is a little more complicated kasi you can absolutely multiply two different quantities to each other or divide them. For example, yun nga, momentum is mass times velocity. Speed is distance divided by time. Yung mga ganong cases na. So pwede na tayong mag-operate on different quantities. As such, hindi na rin pwede na basta-basta i-add or subtract ang uncertainty kasi hindi naman na addition and subtraction ang ginagawa natin. So when doing multiplication and division, so you first convert them, the uncertainties to relative, and then you add them together. So ang example ni manual natin dito ay body mass index, which is your person's mass over the square of the person's height. So if I were to write this down as a mathematical formula, BMI is equal to mass in kilograms divided by square of the height. So ang measurements natin dito ay 65 plus minus 2 kilograms and height 1.61 plus minus 1 meters. Ay, 0.01 pala. Sorry. So to compute the BMI with uncertainty, sabi niya, the first step is to convert all the uncertainties to relative. So gagawin nating percentages ito. So M is equal to 65 plus minus 2 kilograms divided by 65 kilograms times 100%. And similarly, for your height, it's 1.61 plus minus 0.01 over 1.61 times 100%. So skipping the calculations, we get for the mass, it's 3%, 65 plus minus 3%. And for the height, it's 1.61 plus minus 6%. Now let's just clear this up for a bit para mas malinis tignan. Okay, so the next step after we determine the relative uncertainties is to add the relative uncertainties together. So note that the relative uncertainty of the height is added twice kasi squared siya daw. So the total uncertainty is 0.6% plus 0.6%, added it twice, plus 3% is equal to 4.2%. So next, after determining this, we now have the relative uncertainty of the BMI itself. Ngayon, the next step now would be to calculate the actual central value of the BMI. This is determined by just dividing your central values. So you have BMI is equal to mass 65 central value divided by central value of your height squared. I'm going to skip the calculations again. So this is 25. So in relative uncertainty terms, si BMI mo is calculated as 25 plus or minus 4.2%. Ngayon, the final step would be to convert it back to absolute. So the final answer would be 25 plus minus 1. That's it. So one other thing to remember sa multiplying uncertainties, kapag may constant na multiplied, this entire paragraph can be summarized to just multiply the constant to the uncertainties as well. No problem with that. Next is multiple measurements. So ito naman, let's see here. Let's just delete this for now. So kapag nagme-measure kayo in experiments, the normal thing to do is do it multiple times. Each try of a measurement is a trial, as it is normally called. So repeated trials normally make your measurements better. So this is one important thing that I will leave to you to read on your own. So multiple measurements and the concept of deviation. Basically, sa multiple measurements, there is a specific technique that involves taking the average of your central values, tapos taking the value endpoint that's farthest from the central value and taking their difference and making the largest difference the uncertainty of your multiple measurements. Next is deviation. So deviation is a measurement of how far your measurement deviates from your true value. So this is related to your precision and accuracy. So to calculate absolute deviation, it's just your central value minus accepted value. So your accepted value comes from your experiments. Central value is your experiment pala, sorry. And accepted value is your theoretical or true value. So similarly, kapag relative deviation naman, you just divide everything by your accepted value. It's like a percentage, basically. So you can read this along with the multiple measurements. You can read deviation on your own. So now we move on, lastly, to acceptability ng measurement. So how do we know if your measurement is acceptable? So there are two ways. So we can do this by checking if the accepted value is greater than the blah, 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 or less than this. So basically, this just tells you, limbawa, using our initial example of 54 plus minus 0.5, na nasa loob lang siya ng range na ito. That's it. Acceptable siya pag nasa loob. And another way is if you check if the uncertainty is greater than your deviation. So that concludes your lesson. So let's look briefly at your data sheets and questions. So ang experiment na ito, most of the rest of the time, you will be answering these as a group using the communication channels that are most convenient to you. Ngayon, first, may isang table tayo dito na titingnan ninyo if these uncertainty measurements are represented correctly or not using significant figures and yung two rules na diniscuss ko earlier. Pangalawa is a conversion between relative to absolute and vice versa. So again, this is just a conversion of percentages to numbers and vice versa. So you can use the course material so far to guide yourself on how to do this. Number 3, it's just a trial on how to report multiple measurements. Number 4, uncertainty propagation din. Note here na hindi nagmamatch yung units nito. So you will have to do some unit conversions to first match the units before answering. Kasi in cubic centimeters ang hinahanap ng question 4 na volume. So this will incorporate concepts of multiplication ng uncertainties to answer. So lastly, ito, related din, acceptability. So using the last concept we discussed. And the last section, questions. So ito ay generalized questions lang that you can answer nga as a group again. Mag-discuss kayo as a group on how you answer this. So when you come to an agreement, yun yung ilagay niyong sagot. So copyright notice last dito. And again, as I have discussed dun sa orientation, please include dun sa end ng experiments ninyo itong paragraph na ito. Ito yung I blank blah 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 swear upon my honor blah blah blah. Write your following and affix your signature. Ilagay nyo lang dito sa kahit saan dito sa last page. So that concludes our short discussion. May mga tanong ba kayo about the concept so far? Wala naman? Okay. So from here on out, ay, teka. Bakit po 0.52 rounded up? Kasi we want one significant figure lang. Teka, share ulit. 0.52. Kasi we want to round up. Ito na yung rule niya sa rounding off. If x, the last digit that you want to round off, is 5 and there are non-zero digits, so you just round it up. So ayun, this is just following the standard round off rules. So correct me if I'm wrong kung mali ang ano ko dito. Sir, x is to the right of the number. Okay. Teka. X is to the right po of the number that will be rounded off. Yes, but sa example natin, 0.52, dalawa kasi yung significant figures niya, 5 and 2. Pero ang gusto nga nating rule ay one significant figure lang. Kaya i-round up natin. So, correct me if I'm wrong, I think yan, based on this rule. Pero baka mali ako. Double check nyo na lang. Pero yung point is, we just want one significant figure. So pwede ngang i-round, basta i-round lang ito using the round off rules. So, non-zero digits. Oo nga, parang may ano nga dito sa slides. So just confirm it with external sources. So I might be wrong on this. Let's just double check. Pero anyway, the point is we just want this significant figure here. So for the rest of the time, if wala nang questions, meron pa ba? Okay, mukhang wala naman na. For the rest of the time, you can use it to answer the course material, this manual here, para magawa nyo na as a group. You can use the communication channels given to you, Discord, or you can set up your own. PM na lang kayo ng isa't isa or whatever. Pwedeng Facebook or whatever. Also, you can also PM me if you have any questions here. Pwedeng i-PM nyo ako sa Discord or sa email. Pwede kayo mag-email. Alternatively, I will be leaving the Zoom meeting open para pwede kayo pumasok at any time during class hours to ask anything. So, that's it. Okay na tayo. This concludes our session. Adjourn na tayo. Thanks for listening, guys, and good luck sa experiments.